All right, so lime emits a bright light when heated to a high temperature. Lime light used to produce a light that could be focused on a single spot on a stage. So that is not just a common phrase, lime light. It's shine the limelight on them. That's like a legitimate thing. The flower pots seen here were coated with a solution of lime and water. Okay. Two or more names for the compound can be confusing. Chemists use a single system for naming compounds. So would you call these limelight flower pots? Would you... Okay. So anyways, there's a naming convention for chemicals. All right, and a naming that's what we're going to talk about today is how do you name the molecules? How do you write a formula to represent the ratios of the atoms or elements that make up these molecules? And so what information do we need for the name and the formula of an ionic compound? Well, the name of an ionic compound must be distinguished by the compound from other ionic compounds containing the same elements, right? Most organic material has like carbon, oxygen, hydrogen, and some other stuff. And we need to have we can't just say, oh, this is carbon, hydrogen, oxygen stuff, right? We got to have a very specific way to represent that. So these objects are coated in compounds of copper and oxygen. Based on the two colors of the coatings, the copper and oxygen must form at least two compounds. So they're saying there's copper, the oxygen in the air somehow interacts with the copper and it changes the color. So there must be two names to distinguish the red copper oxide from the black copper oxide. In other words, it's a combo of copper and oxygen. And one discoloration is red, the other is black. So then a compound made of only two elements is called binary, right? Binary means it has a base of two, or there's two things, like a bicycle is another way to remember that. Naming binary ionic compounds such as sodium chloride and cadmium iodide is easy. The names have a predictable pattern. The name of the cation is just the name of the element followed by the name of the anion, and as we learned in a previous section, that usually has an "ide" attached to it. So this table lists 8 common anions, and the name for the anion formed by adding the suffix "ide." So fluorine becomes fluoride, chlorine becomes chloride, bromine becomes bromide, iodine becomes iodide, oxygen becomes oxidide, sulfide, nitride. And so these are all, notice that all of them have a negative charge, right? And if you remember, the negative charge comes from them gaining an electron or 2 electrons or 3 electrons, okay? And they're nonmetals. So anion also, remember, is a negative charge. So metals with multiple ions, many transition metals form more than one type of ion. Many paint pigments contain compounds of transition metals. So look at copper. Copper has a +1, a +2, a +3. Or no, just a +2. Iron has +2, +3. Now what that means is it has a positive charge of 2 because it gives off or literally transfers 2 electrons in this particular case. And in this particular case, it transfers 3 electrons. In other words, it's willing to donate 3 of its valence electrons to an anion. Okay. Notice that titanium has 3 different types of ions. They give off 2 electrons, give off 3 electrons, or give off 4 valence electrons. So the table shows copper 1 ion with a +1 charge and copper 2 ion with a +2 charge. These ions names distinguish the red copper, which is oxide, and copper 2 oxide. So that's the difference. That's why one's black and one's red, based on the number of electrons they give off, okay? So the formula for copper 1 oxide is Cu2 oxygen, all right? So what that means is 2 molecules of copper to 2 atoms of copper to 1 atom of oxygen, because it takes 2 of the +1 ions to balance the charge of oxygen's -2 ion. So then the formula of copper 2 oxide is just CuO, because it takes only 1 of those. So we're talking about writing the formula, but we're also trying to explain that you could have 2 coppers to 1 oxygen, and that's a different type of molecular structure than, say, 1 copper atom per 1 oxygen, okay? But the oxygen ion has a -2 charge, and there's 2 ways that that could be addressed. In one particular way, it's a black color, and the other particular way, it's a red color. Polyatomic ions, this is more than 1 or more than 2, right? So before we said there are binary ions, now these are called polyatomic, poly meaning many. Up in the upper right-hand corner, there's an electron dot diagram that models the group of atoms that includes 1 nitrogen atom to 4 hydrogen atoms, right? So nitrogen is group 14, or no, group 5, actually. Wait, let me think for a second. Group 15, yeah. And anyway, so the ammonium ion includes 1 nitrogen and 4 hydrogen atoms, and then down here we have an ammonium ion, and ammonium ion loses its valence electron as it forms. This loss leaves only 10 electrons to balance the charge on 11 protons, so the ion has a positive charge. So I was trying to do the math real quick, and then I realized, wait a second. So if nitrogen has 5 electrons, 5 valence electrons, and it gains 4 other additional electrons, 1 electron from each hydrogen, that gives you a total of 9 valence electrons. Is that the stable number? No, what's the stable number? 8. That's why it's saying that it loses 1 electron. So when it loses that 1 electron, the overall ion will have a positive charge. Ammonium ion is a positively charged polyatomic ion. Okay, does that make sense? We'll do some more work on that. So in polyatomic ions, here's a list of polyatomic ions, but a covalently bonded group of atoms that has a positive or negative charge acts as a unit is a polyatomic ion. Now remember, ion is a way that we say that you have a positive or negative charge in an atom, but sometimes you can have a molecule made up of 3 or 4 elements that behave in that same way. In other words, they have a positive or negative charge. So here's a list of polyatomic ions that are anions, negatively charged, with the exception of ammonium. So hydroxide is just 1 oxygen and 1 hydrogen, but that can have a -1 charge. If you look at carbonate is 1 carbon, 3 oxygen, but that has a -2 charge. Okay, and so these will act just like ions. Okay, so writing formulas for ionic compounds, it basically boils down to matching up the charges. We like 0 charges. So use the name of the ionic compound to write its formula. The symbol of the cation is first, followed by the symbol of the anion, right? So use subscript to show the ratio of the ions in the compound. So parentheses are used with the subscript for polyatomic ions. So for example, the formula for iron hydroxide is Fe, this is the iron part, and then hydroxide, if you look at the other screen, remember hydroxide was 1 oxygen and 1 hydrogen, and it has a negative charge. So iron hydroxide formula is here. And then how many polyatomic hydroxide ions does it have? 3. So it's 1 iron atom to 3 hydroxide polyatomic ions or molecules. Does that make sense? Okay. Now, if it doesn't have that parentheses, in other words, it's really 1 iron, 3 oxygen, and 3 hydrogen. That's the important thing to keep in mind. So because all the compounds are neutral, the total charges of the cations and anions must add up to 0. Suppose an atom that gains 2 electrons, such as sulfur, reacts with an atom that loses 1 electron, such as sodium. There must be 2 sodium ions for each sulfide ion. So then the formula solution would be sodium sulfide, would mean that I'd have to have 2 of those sodium ions, which would yield a positive 2 charge, or actually to combat or balance the negative 2 charge from the sulfide. Okay? So the negative 2 charge in 1 sulfide ion has to be balanced by the 1 plus charge on 2 sodium ions. Okay? So when we're writing formulas for ionic compounds, what is the formula for calcium chloride? So the first thing we got to do is we know the name of the compound is calcium chloride. How do we solve that? Well, we know that calcium, well, you don't know it, but you'll learn it. Calcium has a charge of +2. Right? Chloride has a negative charge of 1. Those have to balance. So how do I make a molecule that has a 0 balance? Well, I have to determine the ratios. It takes 2 negative charges to balance the +2 positive charge. So I'll need 2 chloride ions for each calcium ion. So the formula for calcium chloride would be CaCl2. Then each calcium ion loses 2 electrons, and each chlorine atom gains 1 electron. Right? So calcium is a group 2. That means that it has 2 valence electrons. Chlorine is a group 17 or 7b, which means it has 7 valence electrons. So it's looking to gain 1 electron. So you have to, if calcium's willing to give up 2 of its valence electrons, then you're going to need 2 chlorine atoms to accept 1 electron each, and they'll both have 8. Write the formula for calcium oxide. Well, it takes 1 calcium. Remember, calcium ion has a positive charge of 2. Oxygen is group 16 or 6b. That means it has 6 valence electrons. But the oxide will have a negative 2 charge. So it'll just accept 1 calcium. In other words, the calcium will give off 2 electrons, and oxygen will accept those 2 electrons. And then it'll have 8 electrons in its highest energy level. What about copper sulfide? Well, it takes 2 copper 1 ions, each with a positive 1 charge, to balance the sulfide, which is a negative 2 charge. So the formula will be Cu2S. And that's basically it. All right, we'll skip past that for time's sake. So what information do the name and formula of the molecular compound provide? Well, the name and the formula of a molecular compound describe the type and number of atoms in a molecule of a compound. Naming molecular compounds have some key things here. The general rule is that the most metallic element appears first in the name. The further it is to the left on the periodic table, those names are first. These elements are, well, I just said that. If both elements are in the same group, the more metallic element is closer to the bottom of the group. The name of the second element is changed to end in the suffix "ide," so carbon dioxide. Based on the ions, we give different prefixes. If it's just one ion, we would say mono, like carbon monoxide. If there were two oxygen, I would say carbon dioxide. Okay? So these are the prefixes based on the number of atoms you have. And it's mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. And those are normal prefixes, right? So two compounds that contain nitrogen and oxygen have the formulas N2O4 or NO2. So the name of the compound in the formula N2O4 is dihydrogen, right? Because it's nitrogen, and there's two of them. Tetraoxide, because there's 4 oxygen. The name of the compound in the formula NO2 is I can never say this one, mononitrogen dioxide. Okay? So when you're writing the formula, to write the formula for a molecular compound, write the symbols for the elements in the order the elements appear in the name. All right? The prefixes indicate the number of atoms of each element in the molecule. The prefixes appear as subscripts in the formula, and if there is no prefix, there is only one atom of that element in the molecule. Okay? In other words, if I just say N and you don't write a subscript 1, right? So you should only see a subscript of 2 or 3. The little numbers below is what subscript means. So what is the formula of diphosphorus tetrafluoride? Well, di means 2, so that means I have 2 phosphorus, right? Tetra means 4, so I should have 4 fluorine atoms. So I basically know what I'm writing down. So I'm going to have P2F4. Does that make sense? Just by the name. And once you get good at this, you could read the name and you'll know what the chemical composition is, or you could see the chemical composition and figure out what the name is. One of the things I talked to you guys about is Mr. Adams was saying that potassium bicarbonate is something that you can take. Well, what does that mean? That means that I'm having 1 potassium to 2 meaning 2, carbonates, which is a combo of carbon and oxygen. So, real quick, which of these formulas describes a binary ionic compound? Somebody said C. It's actually B. I could see where you would think it was C. It's definitely not A. It's definitely not D. What is the correct name for this one? It's carbon and chlorine. And there's 4 chlorine to 1 carbon. So what do you think the correct name is? No? So I'll give you a clue. It's either C or D because the chlorine, there's 4 of them and has to end in "ide." So it'll say tetrachloride. So it's not A, it's not B, it's either C or D. The question is, do we want to call it monocarbon tetrachloride because technically there's 1 carbon? Or do we just call it carbon tetrachloride? You don't have to, on the first name, you don't normally do that. But sometimes you do, like carbon monoxide. But oxide is, well, we'll get into that later. Okay, that's all I got today. Any questions? All right, cool.